My name is Janusz and I will talk today about quantitative benchmark. So we will evaluate data with plenty of algorithms quantitatively. So let's click quantitative benchmark. We are in our benchmark evaluation. So we go to our favorite branch. So this branch relates with quantitative evaluation of HDMapping-LIO, LiDAR Odometry, RESPLE, GenZ, and so on. 20 of algorithms. I hope we will see everything. Step 1, following instructions according to HD mapping. So this is our website, and follow instruction. You can install software. So you have quick start on Linux, or you can download software on Windows. I think this movie is for 998, so please be aware to for the current version. We follow step 2. In step 2, we have to follow plenty of benchmarks software that we created. You have to run 20 of them. You have separate movie for each of them. So first of all, you have to prepare ground truth, then you have to execute these experiments separately for each algorithm. And once you succeed, you're supposed to see following folders. I will show you these folders now. Okay, so you have in data, you have these folders from here to here, and we will use them. We will have, yeah. So step 3, I'm working on Windows, so hopefully it will work the same for Linux, but if not, just let me know. So we prepare HD mapping project using our tool according to the movie, and then we have to save data. In TOM format. So I will just open the project. I did it for you just before. So I will use our project. So this is our software. You can see version 0.98. So we open project. The project is located in data. So we have project 20, and then we open it. So you can see it is opened in console and everything is written here. And now you have to just load sessions and wait a little, because you are loading 20 sessions into one coordinate system. It is already prepared for export. So please be aware that maybe you should back to previous movie. Every time I am giving instructions and movies, so it should be sufficient to follow all steps. So you can see that preparation it can be done with this movie. So if you have any problem on certain step, please write issue to me. I will be happy to respond quickly. So still it is loading. We have to wait a moment. Okay, so it is loaded. So this is our system. This is our system of all our trajectories, and you can see some of them, they are very promising, some of them they are not. So what we will do, we just go File, we save all trajectories as a TOM, txt. So we are saving, and you can see they are saved, and we can follow further instructions. So what we do, create folder trajectory TOM. So we have following data structure. We have our data, and we have to create here our folder. So we have data, and we will prepare folder. Okay, we have folder. Copy data to this folder as follows. So we just go inside, and we have console, and I will copy everything. So let's make a copy. Let's take a look if I have everything inside. So we copied and we have all files inside our folder. So we can make now step 4. We can plot trajectories. So follow instructions on this repo, evaluation repo. We are using this evaluation scheme, so you can use this Python scripts to draw and to make quantitative evaluation. You can draw your trajectories and you can draw plenty of things. So it is very useful for quantitative evaluation. So let's back to our instruction. I don't know where it was. Maybe it was here. No, it was here. Okay. So back to our instruction. We have to execute a following command after installing. So once we go to our folder and once we have installed everything, we can just simply plot trajectory with this command. So, oh, we don't have VoxelMap. Why we don't have VoxelMap? Okay, I will fix it. I will fix it by copying by hand, and I will fix. Maybe in instruction do we have it? I think we will copy this one. I will check something wrong with. Okay. Copy. So it was not copied. So just read error and then you can simply fix it by your own. So the file was not copied. That is why I am suggesting you to read carefully what's supposed to be and where. So everything should be copied from here, and the files should appear here. So this one was missing, but don't worry, everything is documented. So please follow this one. Okay, so we have our trajectories. There are trajectories, and we can now zoom in, and you can see our data. So this is the plot 2D plot, and here you have 3D plot. And I will try to turn off all trajectories, and I will try to show you some advantage of 3D. So I will try to show. Okay, this one no, this one yes, this one yes, this one maybe yes, this one no, this one yes. So what you can see from top view, you can see something here, but no, I have to make it zoom out. Maybe this one. Okay. So I will show you the advantage of 3D above 2D. So our tool can give you also insights about the quality of the trajectory, so you can see how the trajectory looks like in 3D. So you can see some, let's say, different behaviors like zigzags and so on, and you can choose your own favorite trajectory based on this 3D. Top view 2D is not so much sufficient for that purpose, but still it is very good for publication. So plot trajectory is done. Now we calculate absolute trajectory error. So we go to our folder, and then we calculate everything. So we are calculating absolute pose error, and we will concatenate results into this table. So you can see here that we have this row here. This is for HD mapping. Sorry, it is for. Oh, this is for. I will try to do it again. So let's make like this. We go to our folder, and then we calculate everything. Oh, maybe I have to make one by one. So, shortly speaking, it is quite naughty. So we make like this. Okay. Oh, maybe the instruction is not so much proper. I have to change instruction. HD mapping trajectory. So it is not complete instruction. We are starting from the Faster-LIO. We are missing some instruction. Don't worry about it. I will find. I have some helpful information here. So I will just improve instruction, and then we will back to this. So what we had in this instruction, what is missing in this absolute pose error, we are missing definitely this one, HD mapping trajectory, and then we are missing CT-ICP, we are missing DLIO, then DLO, then we have Faster-LIO. Okay, so we have commit changes, and now we have everything. We can continue our movie. Okay, so what we have: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Okay, so we have from HD mapping-LIO, so we have HD mapping-LIO, we have here. Still it is calculating. And we can copy this one to our we can make concatenated table here, so you can see that this is HD mapping-LIO. So we have output HD mapping trajectory, and we have our results. Then we have CT-ICP, and we have this one. If I make some mistake, definitely I will fix it, but it looks everything promising. So just let me know if I make some concatenation copy error, but I think it could be somehow automized to reduce operator error. Let's see, but we will see. Okay, so we have CT-ICP. I will check again. If it is working. So I will copy all of these. and then I will paste, and that's it. The same we have with this relative pose error. So if we copy and if we go to our folder, then we can it's not copied proper. Okay, I will close it. So you can see that everything is working somehow, but this one was not copied correctly. So I will copy again. Copy. You can see it's quite difficult, but don't worry. Just I'm showing you solution. So please, if you would like to improve it by automating this one, you are always welcome. For me, it is more important that this is functional and I can do my research. Okay, so what we have everything here. We have all parameters, all quantitative results. So we have max, mean, median, mean, RMSE, standard deviation, and it can be useful for justifying which trajectory is best. Obviously, if you take a look into the values, if you have, let's say, mean, or let's say STD, you look for the smallest value. For example, this method is 003, and it is, according to this benchmark, best one. And here is also this one. So what I can see here, our method is performing best according to this benchmark, but it is biased because it is our own benchmark. So I will try to make it much better with other benchmark, in the sense that I would like to reduce or eliminate my bias because bias of my approach. Yeah, so I really encourage you to use this framework to make your own benchmarks, and please share with me your comments and your results. Okay, so shortly speaking, we have everything we need. We have 3D, we have 2D, we have plots, we have tables, so we have all to perform quantitative evaluation. What I like so much is that in our tool we can simply choose, for example, most smooth trajectory, very easy, very quick. So I can just by clicking removing trajectories that they have some spikes and so on. Oh, this one. So KISS is with spikes. I will remove it. Okay, so most of these trajectories are similar, so we can compare absolute trajectory error and so on. The naming. I received plenty of different reviews, and here in this benchmark we are using this terminology: APE, absolute pose error, and RPE, relative pose error. It was the naming is always different, and I hope all of us we can agree what we talk about. So this movie will be here for those who are interested in that. So please share your thoughts with me. See you soon.